Let us look at how Venn diagrams can help us solve probability problems. We're trying to answer those questions there. Let's take them one at a time. The sample space S has those outcomes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then there are two events A and B. Event A has outcomes 1, 4, 7, and 9. Event B has outcomes 2, 5, 7, 9, and 10. We want to draw a Venn diagram to represent that information. I want to draw two Venn diagrams. The first diagram is for the outcomes. I want to illustrate or to represent the outcomes of those events. So first of all, we start with our sample space, S, and then we have our A and B inside. The best thing is to compare A and B and check what they have in common. Clearly 7 and 9 are common in both. So start with the common outcomes. So 7 and 9 are common. Then go back to A. 1 and 4 still need to be put in there. And this is where we put the 1 and the 4. Then go to B. 2, 5, and 10 should be put inside as well. They should be inside B. And this is where we put them, 2, 5, and 10. Right, then check your sample space S. It has numbers 1, 2, 3, 4 up to 10. We have entered these red ones here. Which numbers are still missing? You will notice 3 is still missing, so we put it out there. 6 is still missing, we put it somewhere there. And 8 is also missing. So this is the Venn diagram showing the outcomes. I want to draw another Venn diagram, but this time I want it to show the probabilities, not the outcomes, but the probabilities. So you do the same thing, your sample space and your two events A and B. Right, so start with 7 and 9. So 7 and 9 are in the intersection. There are two numbers in the intersection. But we have a total of 10 numbers altogether. So the probability that you will pick a number that is common between A and B should be 2 out of 10. And 2 out of 10, we can write that as 0.2. So that region there has a probability of 0.2. Then in the first one, the 1 and the 4, there are only two numbers in that part of the Venn diagram, and that is 2 out of 10. So the probability of picking a number that is in A alone, just in A alone, will give us another 0.2. So this is also 0.2. For B, we have 2, 5, and 10, three numbers out of 10, which makes it 0.3. And then outside A and B, we have 3, 6, and 8. So we have three numbers outside. And the probability, therefore, is 3 out of 10, which is equal to 0.3. You need now to check whether 0.2 plus 0.2 plus 0.3 plus 0.3 will give you 1. The total should be equal to 1 if your answer is correct. Now let's apply this now to answer these other questions. In this question, we want to write down the outcomes of A and B. These are the outcomes. So there is a difference between outcomes and probabilities. So the outcomes of A and B. A and B is that part there. And there we have 7 and 9. So 7 and 9 are the outcomes. So that is our answer for that part. Then the second part says, find the probability of A and B. So to find the probability of A and B, we obviously should know that this is A and B. That region there is A and B. And the probability of that region is 0.2. That is how we use our diagrams to answer these questions. You can still get your 0.2 by looking at the first diagram there. Because A and B, as long as you know that A and B is that common region there with 7 and 9. Now 7 and 9 is 2 outcomes out of 10. That will still give you 0.2. So we want the outcomes of A and not B. This means the outcomes should be inside A and outside B. So what is inside A and outside B? You need to think about that. So inside A and outside B, that should be 1 and 4. So 1 and 4 are inside A and outside B. So and means intersection. So we are looking for outcomes that are in the intersection of A and not B. All right. The second part says find the probability of A and not B. I just want to write it differently now. It's the probability of A and means intersection. You can put and, but it means intersection. Not B means B complement. So this is exactly the same thing as that one there. Right, how do we use this diagram here, the second diagram? All we need to know is the region A and not B is this region here. This is the region A and not B. And there clearly you have a 0,2. So you get your answer from that diagram. Okay. Then for this one, the outcome for not A and not B. So this time, we are looking for outcomes that are not in A and they are not in B. And means intersection. So not in A and not in B. If you check clearly there, you will notice 3, 6, and 8. 3, 6, and 8 are not in A and not in B. Those three there. And that is our required answer for that one. And then the probability of not A, I'll write not A like this, and not B. So it's not A and not B. How do you use the probability diagram there? As long as you know that not A and not B is the region outside A and B, you will then know why your answer should be 0,3. So it's 0,3. A or B simply means everything that is in A together with everything that is in B. That is your set there. So you'll notice it's everything really except 3, 6, 8. So let's write that down. It's 1, 2, 4, 5, 7, 9, 10. It's just everything except the 3, 6, and the 8. And then for the probability of that outcome, we said it's everything except 3, 6, 8. So it's actually the 0,2 there and that other 0,2 there and the 0,3. You can get your answer from there. So it's 0,2 plus 0,2 plus 0,3, which will give you 0,7. This answer you can still get from there because look, there is 1, 2, 3, 4, 5, 6, 7 of these out of 10, which will give you 0,7. And number 6, we want A or not B. So this means we take everything that is in A and everything that is not in B and we put them together into one set. And that will give you 1, 3, 4, 6, 7, 8, 9. 6, 7, 8, 9. All right, now let me check that. So it's everything that is in A. So that's everything that is in A put together with everything that is not in B. Now, everything that is not in B is 3, 6, and 8. So we need to take the 1, 4, 7, 9 and the 3, 6, 8 and put them together. That is what we should get there. Then for the probability, as long as we know that the region we are looking for is all that, it's all that as well as this one outside. Then we are going to add the 0,2 plus 0,2 plus 0,3 to get 0,7. Again, you can get it from realizing that you have 7 numbers in A out of 10. It's not A or not B. Remember what this means is we take everything that is not in A and everything that is not in B and we put them together. So what is not in A? Not in A means clearly the 3, 6, 8 are not in A, and also the 2, 5, 10 are not in A. So these are not in A and those are not in A. So we take those and we shall put them together with everything that is not in B. What is not in B? Do you see that 1 and 4 are not in B? And also, obviously, 3, 6, 8 are not in B. So we take all those numbers and we put them together. We don't have to repeat a number. So we just write 3, 6, 8 once. So your answer should be everything really except 7 and 9, which is 1, 2, 3, 4, 5, 6, not 7, then 8, not 9, but 10. Let's look for the probability of not in A or not in B. If you look at the probability diagram, the numbers we are looking for should be that number there and this number here and that number there. That will give you the same answer as these 8 here, because these are 8 here out of 10, which will give you 0,8. Otherwise, just add those numbers 0,2 there plus 0,3 plus 0,3, and that will still give you 0,8. Right, if they are independent, remember, if they are independent, then we expect the probability of A and B to be the same as the probability of A multiplied by the probability of B. So we need to take the left-hand side, see what answer we get, and then the right-hand side and see what answer we get. If the answers are equal, then the events are independent. So the left-hand side is probability of A and B. Right, we did work it out earlier on. The probability of A and B, we said will be 0,2. It's 0,2. This is A and B there. So these numbers are in A and B. So it's 2 of them out of 10. So it's 0,2. And the right-hand side is probability of A multiplied by the probability of B. Now the probability of A, how many outcomes are in A? There is 4 out of 10. So it's 0,4. Multiplied by the probability of B. In B, there is 5 out of 10, which is 0,5, also giving us 0,2.